Hi everyone, and welcome back to GISC 125, Mapping and Spatial Thinking. And today we're going to explore what GIS is all about. And recall that GIS stands for Geographic Information Systems. So in the previous video lecture, I kind of identified what a map is, the three types of maps, and how it benefits in communicating information. We actually looked at probably 4 different types of maps. So what is GIS, and is it simply a map? So a Geographic Information System, or GIS, lets us visualize, question, analyze, and interpret spatial data to understand relationships, patterns, and trends. Therefore, it's much more than just simply a map. So it allows us the ability to capture data, store that data, manage it in a way to keep it organized. We can then query that data, we can analyze it, and we can display this spatial information. So a working GIS integrates 5 key components: hardware, software, data, people, and methods. And we'll kind of go through these. So hardware is just the computer on which a GIS operates. So today GIS software runs on a wide range of hardware types, from centralized computer servers to desktop computers, to web-based GIS implementations in the cloud, such as ArcGIS Online, which we're going to be using in this course. And GIS software provides the functions and tools needed to do the storing, analyzing, and displaying of the geographic information. Key software components are tools for inputting and manipulating of geographic information, a database management system, and tools that support geographic inquiry, analysis, and visualization. So a graphical user interface for easy access to these tools. Again, in this class we're going to be using ArcGIS Online software for our GIS applications, and so that's going to be the interface that we're using. So data is possibly the most important component of a GIS. So geographic data and related tabular data can be produced in-house, produced or purchased from a commercial data provider, or it's often accessed free from government and non-government organizations. And that's how we're going to pretty much get our data, from kind of free open source data sets from governments and non-government organizations. And then GIS technology is of limited value without the people who manage the systems and develop plans for applying it to real-world problems. So GIS users range from technical specialists who design and maintain the systems to those who use it to help them perform their everyday work. So basically you can have like a GIS technician all the way up to kind of system analysts who oversee the whole operations of GIS. And to make GIS systems work properly requires not only necessary investment in the hardware, software, and data, but also requires knowledge in utilizing GIS technologies. So the methods are the procedures followed to answer the questions needed to be resolved. So methods in GIS include how the data will be accessed, how it will be stored, how it will be managed, processed, analyzed, and finally presented as outputs for a particular application. So what is GIS? So GIS allows us to, as I mentioned before, to capture, store, model, present complex systems using geographic or spatial data. So how do we do this? Well, GIS allows us to break down the landscape or the earth into multiple layers and see relationships between these layers. So in this image, we can see a representation of these layers in GIS, how the GIS would visualize it. So by looking at this data, we can tease out possible relationships that might not be otherwise able to see. So for example, we have the real world, and from that real world, we can have imagery like we see in Google Maps. We can have digital elevation models that are going to show you elevation changes, transportation, for example, all the road networks. You can have your address locations, boundaries like state boundaries, county boundaries, census tracts, so forth, water bodies, and so forth. All these things can represent the world. So GIS conceptualizes the world, as I just said, as these layers. And these layers are the mechanism used to display these data sets in GIS. So each layer has a theme, which I just mentioned, like imagery, elevation, transportation. These are different themes. And GIS makes it possible to integrate data from multiple sources. So for example, satellite data, aerial photography, maps that we create ourselves by digitizing, and so forth. And then we can use all this data together to model various things. So spatial data are data that have spatial components. That means that the data are connected to a place on the Earth through unique geographic coordinates that allow the data to be located in geographic space. Examples of spatial data include trees, rivers and water bodies, buildings, transportation networks, land use, crime locations, or air temperature. In short, any feature that has a location on the surface or very close to it is referenced or is referred to as spatial data. In short, spatial data is any data that can be mapped. Non-spatial data is the descriptive of spatial data. For example, in this image, the fire hydrant has a location on Earth's surface, so it's spatial data. But the non-spatial data components of the fire hydrant could include things like the color, the manufacturer, flow rate, the date of last service, or when it was installed, and so forth. These components or attributes about the fire hydrant don't have a spatial component. They are referred to as non-spatial data, or these are the attributes about the fire hydrant. So the power of GIS comes from linking spatial data with attribute data. So why is the ability to link attribute data to spatial data so important? So here we have a table on the left-hand side of the screen here of Idaho counties by the population per square mile. So we can see that under POP 2010 and population per square mile, the last two columns on the right-hand side. It's difficult. The information is useful, but it's difficult to quickly and easily compare densities across these counties. But in this map on the right, which shows the population per square mile, we can quickly and easily show where population density is high or low by using GIS. So by using GIS, we can then link these attribute table, population density, to these county boundaries. And a picture is worth 1,000 words. So what type of map is this? Number one, it's a thematic map because we're mapping some kind of data, some kind of statistics, but it is referred to as a choropleth map. So let's take a look here. And GIS can be used as a tool in both problem solving and decision making processes, as well as visualizing data in a spatial environment. So geospatial data can be analyzed to determine, for example, the location of features and the relationship to other features, where the most and least of some feature exists, the density of features in a given space, what happens inside or outside of an area of interest, and what's happening nearby something, feature or phenomena, and how a specific area has changed over time. So mapping where things are. So we can map spatial locations of real-world features and visualize spatial relationships among them. So here's a map of agricultural districts in green that are laid over soil types. So we can see visual patterns in the data by determining what soil types are best suited for which agricultural district. Here we can map in quantities. So here we can map people map quantities such as where the most and least are, to find places that meet their criteria to see the relationship between places. So here is an example. We have a map of cemetery locations in Wisconsin. This map shows the cemetery locations as a dot. It's a dot density map. And each county is color-coded to show where the most and least are. So lighter means fewer cemeteries, and darker means more cemeteries. We can also map densities. Sometimes it's important to map concentrations or a quantity normalized by area or area. So remember, we don't want to map raw numbers. We want to have a choropleth map that maps rates. So example here, we have mapped the population density of Manhattan. So we can see kind of population density is very high. And again, if you know New York at all, the population density is very low here because this is Central Park, so forth. We can find out what's inside. We can use GIS to determine what is happening or what features are located inside a specific region area. We can determine the characteristics of inside by creating specific criteria to define an area of interest. So here's an example of a map showing noise pollution near an airport in Minneapolis. So if we were to add demographic data from the census to this map, we can determine the socioeconomic characteristics for people that live within the defined noise pollution area of interest. So we can see kind of the noise values. The redder, the higher the noise value. The lower the color, the lighter the green, the less. And then we can map socioeconomic status, maybe median household income. And we can see if there's any correlation between noise and income. Here's another example, finding what's nearby. We can find out what's happening within a data set or a feature of event by mapping what is nearby using buffers. And here's an example of effects on features within a spatial radii of the simulation of an explosion, and kind of using the buffer tools to generate set distances could aid in emergency response to disasters like these. And here we can map change. And so for mapping change, we can change by specific geographic area to anticipate future conditions, decide on a course of action, or evaluate the results of an action or policy. So here we can see land use maps in Massachusetts showing change of residential development from 1951 to 1999. So the darker green area show forest, while the bright yellow show residential development. So applications like this can help inform community planners about policies. So as we can see, urban development has grown significantly over this time. And as it grows significantly, how's that going to affect wildlife? How's that going to affect traffic, congestion, air pollution? Where are you going to build commercial districts and so forth? So as you can see, there's a lot that can be done with GIS, and we're just starting this course, and we're just starting to kind of scratch the surface on what GIS is and all the applications of GIS and how we can think about these problems from a spatial perspective.